All right, let's jump right into this explainer. Today, we're going on a bit of a cinematic journey into the very pulse of our modern digital world. We're tackling a massive visionary question. How exactly do we build an awe-inspiring, totally connected civilization without completely wrecking the planet in the process? I mean, the scale of our technological growth right now is absolutely breathtaking, but it demands a total rewrite of how we engineer our future. So, we're going to break down the data, look at the underlying network architectures, and check out the cutting-edge strategies that major global tech groups are using right now to build a smarter, greener, and far more resilient future. Let's get into it. So, right off the bat, we have to face the music. The sheer speed of this digital revolution has a massive hidden cost. Toxic electronic waste is literally the fastest growing waste stream on Earth. Right now, we're churning out over 50 million metric tons of e-waste every single year. Just let that sink in for a second. That is the equivalent of throwing away thousands of complex, resource-heavy laptops every single second. It's wild. And it's the direct result of this outdated, linear take, make, use, and dispose mindset that the tech industry has been stuck in for decades. Just digging up raw materials only to bury them right back in a landfill.
And it gets heavier. We're building these incredible cloud networks, right? We're putting billions of smart devices in our homes and pushing AI to the limit. But because of all that, within just 10 years, digital devices could account for a staggering 25% of all global carbon emissions, a quarter of all emissions. Why? Well, it takes a monumental amount of power to cool those massive hyperscale server farms, huge energy to train AI models, and vast resources to physically build microchips. Between mining rare earth metals, shipping them globally, and keeping the servers humming, the very infrastructure keeping us connected is quietly becoming a massive climate burden. It's just an entirely unsustainable trajectory for us.
So, how do we fix it? To decouple our tech progress from environmental destruction, we absolutely have to ditch that old linear economy. The only way forward is a robust circular ecosystem. In tech, this means designing hardware that's actually built to last from day one. It means using modular parts that you can easily pop out and repair instead of just tossing the whole device. And it means creating end-of-life protocols where we harvest those raw materials and feed them right back into the manufacturing cycle. We have to literally design the concept of waste out of the equation, keeping those valuable materials in play for as long as humanly possible. Now, solving this paradox, balancing global digital expansion with actually protecting the environment, requires a really intelligent engine. And it all starts with the foundation: enterprise IT infrastructure and high-capacity fiber networks. You can think of these as the invisible central nervous system powering our modern cities. We can't just blindly build more infrastructure anymore. We have to build fundamentally smarter infrastructure. We're talking ecosystems that are incredibly scalable, rock-solid secure, and engineered to be hyper-energy efficient right down to their core. So what does this foundation actually look like? Well, in-building solutions, or IBS, completely eliminate network dead zones so data flows smoothly inside massive structures. Then you have advanced fiber to the home, or FTTH, pushing high-speed data across entire communities. Now, when commercial buildings want to hit those Tri-5-star digital connectivity ratings, which is basically the gold standard for performance, they have to integrate path diversity with automated power backups. By tying these directly into their building management systems, these towers can literally anticipate a power drop, shift the load instantly, and maintain flawless connectivity without wasting a drop of energy. It's brilliant. Okay, let's step up to the next layer, because this is where it gets really futuristic: artificial intelligence. And I know, AI is the ultimate buzzword right now, but here it's an invisible, tireless overseer that is absolutely critical for sustainability. AI is actively monitoring these complex distribution networks globally. It's crunching real-time data to optimize transport routes, balance server loads, and actively shave off fossil fuel use, mile by mile, watt by watt. It turns sluggish, old-school infrastructure into highly agile, autonomous systems that adapt to environmental needs in literally milliseconds. The real-world application of this AI advantage is just phenomenal. Take predictive maintenance. You have algorithms monitoring vibration and heat, predicting a mechanical failure before the engineer even realizes a part is wearing out. Or think about the magic of digital twins. This is where you create a flawless, virtual replica of a physical factory or power grid. Teams can simulate optimizations and push the system to its absolute limits virtually without ever risking real-world downtime. When you combine that with smart incident detection, these AI networks are actively lowering the carbon footprint of the biggest industrial operations on Earth. And when you apply all this intelligence at scale, the transformation is incredible, especially on two main fronts. First, you've got smart commercial towers. These have automated power reserves, IoT sensors checking indoor air quality 24/7, and HVAC systems that automatically adjust the climate based on how many people are actually in the room. Second, you have Industry 4.0 environments. If you step onto one of these autonomous factory floors, it's like a choreographed dance of robotics and digital screens. Every single watt of energy, every single ounce of raw material is tracked and utilized with mathematical perfection. Now, pulling off this industrial transformation takes serious discipline. You usually start by retrofitting older legacy equipment with smart sensors. Then you step up to remote, centralized plant monitoring, which unlocks unprecedented operational efficiency. And hey, this isn't just some theoretical feel-good green initiative. It is highly lucrative. Look at India, for example. Companies like Polycab are driving massive infrastructure projects, and under Project Leap, they registered an incredible 143% growth in their engineering, procurement, and construction segment. It's definitive proof that sustainable, digital-first operations actually drive massive economic profitability. But look, flawless connectivity and automation, they aren't enough on their own. We have to adopt the philosophy of green computing. This is basically a four-part chain of responsibility. First, green design. Engineering non-toxic, super energy-efficient hardware from scratch. Second, green manufacturing, strictly minimizing water use and emissions when you're actually building the stuff. Third is green use, maximizing energy efficiency day to day. And finally, green disposal, guaranteeing responsible recycling. Every single phase of a microchip's life has to be rigorously optimized. And tech companies are getting super aggressive about making this a reality. Take the fintech platform Union Hub. Get this. They've set a verified public target to operate at 120% carbon negative by 2026. Not just neutral, carbon negative. They are actively working to remove significantly more carbon from the atmosphere than they put in. Because these advanced cloud tools require so much power, leading firms like this are balancing their grid demands by pairing green data centers with massive verified ecological restoration projects. They're literally healing the environment while they operate. This whole circular movement is a synchronized global effort, and it relies heavily on what we call ITAD, Information Technology Asset Disposition Programs. It's fascinating to see how different regions tackle this. In India, operators like Green Tech Reman are running massive commercial e-waste collections, using advanced extraction tech to pull highly valuable copper, silver, and gold right out of discarded motherboards. Meanwhile, in North America, groups like the Electronic Recycling Association focus on meticulously refurbishing enterprise-grade laptops and servers to bridge the digital divide for underserved communities. Different approaches, but one unified goal. Of course, making a shift this massive requires a rock-solid corporate action plan. Enterprises have to move away from traditional hardware ownership and embrace device-as-a-service models, basically paying only for the use of the tech, which forces manufacturers to build devices that actually last. They also need to bake ESG metrics directly into their core financial ERP systems, so sustainability is tracked just as ruthlessly as daily revenue. And to top it off, they have to verify their global supply chains using immutable blockchain tracking. That completely eliminates any chance of corporate greenwashing. You can't fake it. When an organization finally weaves together seamless cloud migration, AI-driven operations, and rigorous circular IT recovery, they unlock something truly profound. It's end-to-end sustainable digital transformation. At that point, you aren't just cutting costs or speeding up your network, you're fundamentally rewriting your relationship with the natural world. This unified approach lets massive global enterprises aggressively scale up their business while simultaneously achieving total operational decarbonization across their entire footprint. All of these interconnected systems, these sustainability protocols, they're all pointing us toward a pretty breathtaking Vision 2030. Just picture it. Futuristic smart cities, powered entirely by the wind and sun, where AI optimizes traffic to completely eliminate congestion. Down below, you have autonomous, zero-waste manufacturing plants silently looping materials back into production. Hospitals are linked into digital healthcare ecosystems, analyzing global medical data to save lives in real time. It's a horizon where our most awe-inspiring digital innovations exist in total perfect harmony with the Earth. Which brings us to a really definitive mandate: connected infrastructure, sustainable future, building a smarter, greener, and more connected world. We really need to let that sink in, because this is the absolute standard we have to hold ourselves to. It's the benchmark for every new data center we design, every fiber optic cable we lay, and every smart commercial tower we build. But to actually get there, to achieve a future of this magnitude, our tech progress has to be guided by four foundational human pillars: trust, innovation, insight, and happiness. These have to be our true north. Because honestly, what is the point of a perfectly optimized autonomous factory or a lightning-fast data center if it doesn't ultimately serve human progress? Technology has to elevate the human condition, foster global connection, and fundamentally improve the quality of life for everyone. And that is the ultimate realization of the Chanchal Group Vision 2030. We are standing at the most critical intersection of explosive tech advancement and vital environmental responsibility in human history. We literally have the blueprint in our hands. The AI is ready, the stakes couldn't be higher. So, as we wrap up this explainer, the only real question left is this. Is your organization going to be a passive observer of this new era, or are you going to be an active architect of our connected, sustainable reality? It's time to get to work.